We're going to take a look at a problem that's a little bit more challenging from section 5.4, which deals with factoring general trinomials. So the problem that we're going to take a look at is going to be 4x squared plus 8xy plus 3y squared. Okay, first off, do not panic. Just because you see x's and y's in there does not mean that this problem is going to be impossible. So if you're at that point, talk yourself off the cliff and just continue watching the video. So note that this is in descending order. Okay, so I have a 4x squared, and then all of a sudden I have an x to the first power, and then I have no x. So it is written in descending order with respect to my x variables. You can also take a look at this and say, all right, if I start with a square for my y value, if I move to the next term up, the exponent ticks down, and then when I move up again, the y's are gone. So there is an order and a rhyme and reason to this. The next thing you should do is see if there are any common factors or a greatest common factor that you can pull out. And unfortunately, when we take a look, we'll see that we can't, because as you notice, not all of the terms have x's in them, nor do they all have y's. And you get very close here with a 4, an 8, and a 3. So the 3 kind of mucks this up. So from here, what we're going to do is we're going to try to factor this out, okay? So I know that if I am successful in factoring this, I should be able to write this out as a product of two binomials. So when we take a look at 4x squared, one of the things that you should ask yourself is, okay, do I have, how would I break apart 4x squared? And you do have a couple of choices. Usually we try to break them evenly, and there's really no rhyme or reason behind it. I would just say that it's more force of habit, just because usually that's how problems go, but that doesn't mean that they all will go this way. So now we want to go ahead and take a look at how to break apart this positive 3y squared. So note that the sign in front of the 3 is positive, and that when we go to check our middle term, it is also positive. So we can kind of logically deduce that this will be a plus and a plus, because a positive number times a positive number will give you a positive number, and also a positive number plus a positive number will give you a positive number. Okay, so from here we wanted to figure out how to break apart 3y squared. Well, there's really only one way that we can break apart a 3y squared, because 3 is a prime number, so it would be 3 and 1. And since our since our first terms in each of our binomials are the same, it really doesn't matter which way we put the 3y or the y. So let's go ahead and check. So we would do our outer terms, because we're going to see if we can find that middle term or our middle child. So this gives you 2xy, and then we multiply our inners. So 3y times 2x would give us 6xy, and that is, in fact, 8xy. So lo and behold, I did find my middle child. So then our final solution will be 2x plus 3y times 2x plus y. Or as we had said before, you could have written this as 2x plus y times 2x plus 3y. Either one is fine because of the commutative property for multiplication. So they both will work as solutions.